Hello students, welcome back to VJ Tech Academy. I am Vijay Kumar Jain. In previous lecture we learned how to perform arithmetic operations between two series objects and understood the concept of index alignment. In today's lecture we will learn some very useful series functions like head, tail, sort underscore values. After that, we will learn how to compare series values and perform filter operation. These concepts are very important because they are used frequently while working with real-world dataset. So let's begin. Before starting the new lecture, let's quickly revise the previous one. In the previous lecture, we discussed performing arithmetic operations on two series objects. We also discussed the index alignment. The learning outcome for today's lecture are display first 10 elements of a series, display last 10 elements of a series, sort series values, compare series values with a scalar value, filter only those values that satisfy a given condition. Let's understand each of these one by one. We start with working with head function only. So let's consider this particular series where I have stored the marks for 8 students. In place of displaying the marks for all the students, I just want to display marks only for first 3 students. Amit, Ashok and Anurag, these are the 3 students for which I want to display the mark, that is 40, 50 and 70. Is it possible or not? You have to think. Yes, answer is yes, we can fetch first 3 values of the series directly using head function. Consider the given program. The first few lines is only for creating the series only. Here the marks are stored for the 8 students in the marks list. Here the name of 8 students are stored in the students list. And then I create a series for marks and index is as student name. If I write print sc1.head in the bracket I have mentioned 3. The 3 means what, at how many elements I want to pick from the given series. So it will display first 3 elements of the series. If I do not specify any value, then by default it will display first 5 elements of the series. If I write 6, then it will display first 6 elements of the series. Let's do this activity practically as well. I just create a new program here. I request a student to please write the program with me. Import pandas as PD. I create a list here, say 67, 89, 56, 99, 67, 45, 100 and say 93. These are total 8 students' marks. Fine. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, I create another list name as students Amit, Ashok, Anurag, Priya, Priyanka, Ojaswini, Bhavya, and Arun. So this way I have stored the name of 8 students. Just count it: 1, 2, 3, 4, 5, 6, 7, 8. 8 marks, 8 students. Now I just create the series SE is equals to PD dot series marks, comma, index is equals to student. Close this. Now I just print SE. I also write print SE dot head in the bracket write down 3. So as per discussed, head 3 will display first three element of the series. In this particular case 67, 89 and 56 will be displayed being the first three element of this particular series. Let's run the program. I just save it. Say I have given the name to this particular lecture. Save it. You can save it with any name. Now run the program and see the output. Here the complete series is displayed, but here once you have mentioned SE dot head in the bracket we have written 3, so first three elements are being displayed. Fine. If I do not specify any value here, then it will display first 5 elements of the series. You see, now 1, 2, 3, 4, 5. Amit, Ashok, Anurag, Priya, Priyanka. Amit, Ashok, Anurag, Priya, Priyanka. I did not specify any value, so by default it will display 5 values to you. Even you can write 5 there, so that will also be executed. If I write 5 here, so 5 will be displayed. If I write 6 here, so 6 elements will be displayed. So you can see 6 elements are being displayed of the series. Similarly, we can display the last n elements also using tail function. Fine. So in the program nothing is to be done, just replace head function with tail function, and if you write tail 3, then it will display the last 3 elements of the series. If you do not specify any value, then it will display the last 5 elements of the series, and if you write tail 6, then this will display last 6 elements of the series. Let's do it practically as well. So in place of writing head, just write tail. I write 3 here. So last three elements are 45, 100 and 93, which are for Ojaswini, Bhavya and Arun. So try this. So you see the last 3 values are Ojaswini, Bhavya and Arun. So the same is being displayed here. Ojaswini, Bhavya and Arun. Values are 45, 100 and 93 respectively. If I do not specify here, then if I do not specify any value here, so it will display last 5 elements. So last 5 elements are 1, 2, 3, 4, 5. Priya, Priyanka, Ojaswini, Bhavya and Arun. These are the last 5 values. So you see in the output also Priya, Priyanka, Ojaswini, Bhavya and Arun is being displayed. Got it? So tail function is used to display the last n elements. Head function is used to display first n element of a series. You can see these functions are very easy. No logic is required, only we had to learn how to execute these functions. Next is sorting the series values. Sorting means what? Arranging the elements either in ascending or descending order. Just consider this series where the values are 60, 80, 150, 130, 45, 23, 30, and these values are not arranged either in ascending or descending order. If I want to arrange it, then we can do it very easily using sort underscore values function. So after arrangement in ascending order, the values will become 23, 30, 45, 60, 80, 130, 150. You see, though the position of these elements have been changed, but index will not change. Index mean 23 here is at position mean index 5. So here also we are seeing the index is 5. This will not change. Don't think that this will become 0. Got it? So we do it practically also. Just create the series and just use sort underscore values function, sc1 dot sort underscore values function, then ascending is equals to true. So this will arrange the element in ascending order. If you write ascending is equal to false, so this will arrange the elements in descending order. Let's do it practically. You see the same values I am using here. So what I am doing, just write sc dot sort underscore values. If I do not specify any order, then by default it will be arranged in ascending order only. So I'm executing it directly this way only. This is the original series 67, 89, 56, 99, 67, 45, 100, 93. Now see, after sorting, it becomes 45, 56, 67, 67, 89, 93, 99, 100. Arrange the values in ascending order. Though I have not specified anything, by default, series is arranged in ascending order. If I want to specify the order, inside the series underscore value function, pass a parameter named as ascending is equals to true. So this will also arrange the elements in ascending order only. Fine. So you can see the arrangement values have been arranged here. Got it? If I write ascending is equals to false, so you see the values have been arranged in descending order 100, 99, 93, 89, 67, 67, 56 and 45. So values are arranged. Now before we proceed further, let's discuss one more thing here. If I write this here and try to print this, I run the program again. See, the series is not arranged, though I had mentioned it sc dot sort underscore values ascending is equals to false, but now the elements are not arranged. What is the reason? What is the reason behind it? The reason is, once you sort the values have been shuffled, but the shuffled values will not be refreshed in series object. If you want that it should be refreshed in series object, so the refreshed values should be assigned back in the series. So you have to write it SE is equals to SE dot sort underscore values ascending is equal to false. Then if you print SE, so it will be sorted automatically. Just see it. Now see, the values have been arranged. Okay. So if you want that the series should be sorted, then then you need to refresh the series object by assigning the new values back into series object. If you do not want to write this, you want to write it this way only, you can, but in this case, you have to pass one parameter in place is equals to true. You have to write in place is equals to true, and the job of in place is equals to true is refresh the series object after sorting the values. I run it again. So you see the values have been arranged in the descending order, though I have not assigned the refreshed value in the series object back, but I have passed in place is equals to true. This particular parameter automatically refresh the series object and we get the updated result once we are going to print it. So this is how we can perform sorting operation on series. Next, comparing the series values. As we did arithmetic operations on series objects, similarly we can compare series values. Like here you see, this is the series values 60, 80, 150, 130 and 40. I want to compare this series with a scalar value 70. Say I just want to write greater than 70. So what will happen in this case? Each value of the series will be compared with 70, 60 greater than 70, 80 greater than 70, 150 greater than 70, 130 greater than 70, 45 greater than 70. And you know it, whenever you compare two values, the result is always true or false. Comparison operator always results in true or false. So accordingly, 60 greater than 70 result is false. So you can see at index 0 we are seeing in the Boolean series as false. 80 greater than 70, yes, this is true, so this is true coming. 150 greater than 70, this is also true, so true is coming. 130 greater than 70, this is also true, so true is coming. 45 greater than 70, this is false, so this is showing here as false. So this is the result of comparison. So we are allowed to compare a series object with a scalar value. We just do it practically also. Just write down SC1 greater than 70 and then we will see the result will be displayed like this only. We do it practically. So what I am doing here, I just remove this and I just write SC greater than 60. So wherever value in the series object is greater than 60 will be displayed true, and wherever it is less than 60 will be displayed as false. We just run the program. So you see 67 greater than 60 true, 89 greater than 60, so result is true. 56 greater than 60, so result is false. 99 greater than 60 true, 67 greater than 60 true, 45 greater than 60 false, 193 greater than 60, so again coming true respectively. Fine. So you can compare the series values with a scalar value this way. And sure, you can use any of the relational operator here. It is not like this that only greater than you can write. You can write less than equal to also. So all those values will be having the true result wherever the value of the series is less than 60 or equal to 60. If any value greater than 60 will be displayed as false, or any other comparison operator you want to use, you can use that one also. There is no problem. Now, the next topic is filter. As we know that when you are comparing the series object with a particular scalar value, result is always true or false. So wherever you are finding the Boolean series with value true, those values will be displayed. If you pass this particular condition in a series object, like you are comparing SE greater than 70, so this will generate a Boolean series. 5 values will be generated in this case: false, true, 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 false. Fine. If I pass this condition SE greater than 70 within the series object, so this will compare each value, and wherever we are getting the result true will be displayed. Hence, the output of this particular statement, of this particular filter statement, will be displayed as 80, 150, 130. Let's do it practically as well. I just create the series here and I write SE1 in the square bracket, write down SE1 greater than 70. So first SE1 greater than 70 will be executed, which will result as true or false, whatever will be generated as per the values given in the series. And wherever you are having the result as true, only those values will be displayed. Let's do it practically. So here I write this also, and I write this also. SE in the square bracket, SE greater than 60. So here in this particular case, each value will be compared with 60 and will display the result as true or false. But in this particular case, wherever you are getting the result as true, those values will be displayed to you. We just see it after running the program. So these are the values. The result, once you compare with 60, these are the results: true, true, false, true, true, false, true, true. So wherever you are having the result true will be displayed as output to you. So Amit Ashok is true. The value is 6789. So 6789. Next, Priya and Priyanka. Priyanka value is 9967. So 9967. Next value is Bhavya and Arun. True. Value is 193. So 193 is being displayed here. This is called filter. Okay. This is called filter, which will display only those values that satisfy a particular condition. Got it? This is all about your filter. So what we have learned in today's lecture: displaying the first 10 elements of the series using head function, displaying last 10 elements of series using tail function, arranging the series values in ascending or descending order, comparing the series values with a scalar value, which always result as true or false, and displaying the series values that satisfy a particular condition. This is the practice questions for you. You can try all these questions. I encourage all the students to solve all these questions, as these questions are asked in the board examination also. In the next lecture, we'll be discussing about the series object. If you found this lecture useful, please like, share and subscribe to VJ Tech Academy. Happy learning. Thank you.